An important variable that matters for the masses is the employment variable, the opposite of which would be unemployment. So how we can analyze the dynamics of unemployment using the differential equations? If the unemployment data is measured in thousands, unemployment in a small country is measured by using the following differential equation. So this differential equation guides us about the unemployment in a small country. And unemployment is 150 in thousands. At the beginning of the analysis period, we have to find the time path of the unemployment. This is the initial condition, so we are going to use this information in order to definitize the solution. So this is the given differential equation that measures the behavior of the rate of change of unemployment over time as the unemployment changes. So we are going to rearrange it just to make it matchable with the standard form where the values of A and B can be extracted, and we have extracted these values. So this is the initial condition that was given in the statement of the problem. And now let's look at the values of B, and B is not equal to 0 in this case, so it means that this is a non-homogeneous case, and A is equal to 3, which means that this non-homogeneous case becomes the case where A is not equal to 0. So this is the standard form of, this is the solution formula of the definite time path of the non-homogeneous case where A is not equal to 0. We can put the values of B and A wherever they can be substituted. We have highlighted those areas, and the substitution took place in this step. And then the simplification, like it is done most of the times, the unemployment, it is now modeled in this time path, and we can see that this is the complementary function, this is the equilibrium level of the unemployment. Now we can assess its dynamics, and definitely the stability matter should be addressed here. This is the complementary function, which is the deviation, which is positive in this case, and it is being analyzed over time from 0 till 10 and so on. We started with 0 and gave us the value of 90, and then it started to decline, and consistently it is approaching equal to 0. So the positive deviation is fading away, and when we add it into the equilibrium, we get this series of value, which also is a declining value. So it means that there was a positive deviation, as we saw, and as the time went on, the deviation also nearly approached to 0, and the time path should decline and slide and converge to the equilibrium value, which is 60. So let's look at it in a graphical way. As you can see, time is on the x-axis since it is dynamic analysis, and the unemployment is on the y-axis. So the equilibrium level of unemployment was 60, and the initial level of unemployment was 150 units, and as you saw that the value of deviation was decreasing its positive value, so it was converging towards the equilibrium, and it is now visible from the diagram as well. So we have a time path which is convergent in nature, and we can expect that there will be a stable equilibrium in this case, where we are trying to study the dynamics of the unemployment by using the first order differential equations. Thank you.